Assalamu alaikum warahmatullahi wabarakatuh. Today I'm going to review Chemistry Regent August 17, 2016, Part B2. So in the first question, 51, he's asking about what is the empirical formula for C6H12. We know that empirical formula means I have to simplify the ratio. So it's simplification for the ratio. So C6H12, if we observe 12 is a multiple for 6, so I can divide both by 6, so it's 6 divided by 6 is 1, 12 divided by 6 is 2, so the final formula is CH2. That's the empirical formula for C6H12. Okay. In the second part, he's directing you to table G. Determine the minimum mass of sodium chloride will be dissolved in 200 grams of water. Be reduces saturated solution at 90 Celsius degree. So I have to be aware about the temperature. Temperature is 90 Celsius and it's 200 grams of water. It's 200, so 200 grams of water and 90 Celsius degree. So I go for my chemistry reference sheet. This is table G. That's table G. He's talking about sodium chloride. Here is a sodium chloride, and he asking for 90 degree. Here is a 90 degree. So I go all the way up. I mean the line. I take the reading over there. So that's 40 gram per 100 milligram water. But he asking about 200. 200 gram water. So I'm multiplying here by 2, so I'm multiplying here by 8, so it's 80 gram. So it should be 80 gram. Okay. Question number 53. State the physical properties that make it possible to separate solution by distillation. In distillation, I use the difference in boiling point since the material has different boiling point. That's the way I separate the mixture using steam distillation. Distillation means different boiling points. So that's the way I'm going to separate. Okay. Now, question 54, 55, based on the information. Here's the beaker contain a liquid sample. So what does it mean? A liquid sample of a molecular substance. Both the beaker and the liquid are at, so let's label this stuff. So he said beaker and the liquid at 194 Kelvin. So that's 194 Kelvin. I have the beaker and I have liquid. If you're looking here, so by the time, look here for the time, and at 4, what happened? The temperature started to remain constant. It was liquid, here liquid, and here is constant in that area, means it started to convert, and by decreased temperature, it should go for solid. So that's the solid. Here, the intermediate, so that's the solidification or decomposition, no, solidification or freezing point. That's the freezing point. Now we analyze the graph. Okay, let's go for the questions now. It said what happened to the average kinetic energy of the molecule as a sample first 3 minutes. Now, if you're looking the temperature in decrease, so what does it mean? By decreasing the temperature, decreasing temperature, uh, decreasing energy. Decreasing energy means the kinetic energy is going to decrease, and that's what's going to happen. Identify the physical occurring during the time interval from minute 4 to minute 9. Since I have a constant curve in the temperature, means that's the freezing point. That's the freezing point, as I said before. Okay. Question 56 to 59. Here we have an equation, and he give us a new material, cyclopropane. Cyclopropane. So let's take the question step by step. Explain why this reaction is classified like synthesis. So we agreed before, synthesis reaction 2 becomes 1. I start by 2 compounds, I ended by 1. That's why it's synthesis. So they combine together and give me one molecule. Okay. Identify the class of the organic compound, which is a product. That's the product. It has here halogen, so that's halocarbons. Halocarbons, because this is halogen. Halogen. Explain in terms of molecular formula structure why cyclopropane is the isomer for propene. So propene, alkene, so follow CN, H2N, prop means 3 carbon, so C3, H2 times 3 is 6. Now I get the propene. If you look for the cyclopropane count with me 1, 2, 3. So C3, H6. So both has the same molecular formula, but they have different structure, because this is like, as you see, this one is cycle, and if we try to draw this one, it's C, double bond C, C, here is H3, here is H, here is H2. So they have the same molecular formula, but they have different structure formula. Convert the boiling point. So I have to go up a little bit to see the, okay. He said that the boiling point of cyclopropene is negative 33 Celsius. And he wanted to go to the Kelvin, so I'm going again. Here's my reference sheet. I'm going all the way to the top. Is he give, no, I think it is all the way to the back. I memorize the formula, but okay, here it is. Kelvin equals Celsius plus 273. So that's the formula I'm going to use. Kelvin equal to Celsius plus 273. Celsius here was negative 33 plus 273 equal to 240 Kelvin. 240 Kelvin. Now, question number 6 through 63. He started to give me information. Okay, the lithium atom is 130 picometer. Okay, I'm going to escape the radius of the fluorine. The radius of the lithium ion is 59 picometer. I'm going to change the color now so we can see the difference. The radius of fluorine atom is 60 picometer, while the radius of fluorine ion or fluoride is 133 picometer. Compare the radius of a fluoride ion. So fluoride ion is 133 picometer For fluorine atom was 60 picometer. So that's bigger by, if we did the subtraction, almost like 73 picometer. So the radius of the fluoride ion is bigger than the radius of the fluorine atom by 73 picometer. Okay. Explain in terms of subatomic particles why the radius of the lithium ion is smaller than the uh, radius of the lithium atom here. So if we look for the lithium, it's 3, the configuration is 2, 1. The lithium ion is going to lose 1. So now here I have 2 shells, and here I have 1 shell. So for sure the 2 shell is going to be more than the 1 shell. Okay. Now draw Lewis electron dot diagram for fluoride, and so we know that fluoride is F7, and it's going to gain 1 electron, and in that case it's going to be negative because it has 1 more electron. Describe the general trend of the atomic for period 2 in order from left to right. So period 2, if you go in here, front sheet, we're going to rotate it. Here is period 2, and he said from the left to the right. From the left to the right, the electronegativity increase, the ionization energy increase, the radius decrease. And if you forget that, so I know that the group 2, the period 2 start from lithium and end by neon. So I can easily go for the next page here. Look here, starting from lithium, and here the atomic radius. Look, lithium 130, after that 99, 84, 75. So if it's going all the way, it's decrease, except neon start to increase again. But as we see the trend start from lithium, go down, the atomic radius decrease. Question number 64 to 65. See the evidence as a nuclear reaction represent transmutation. That's easy one. Look, I started by uranium, start, and I end by 2 different elements. So I start by uranium like 1 element, and I end by 2 different elements. That's why it's transmutation. So the first element vanish, and I have 2 new elements. Now the second part, he asking complete the beta decay. So we have zircon 97, 40. He said beta decay means I have electron plus, so here it's 40, so I need here the sum 40. What's plus -1 giving me 40? It's 41, and the sum here should be 97, so here is 97. What I need to do now, I need to go to the reference sheet looking for the element that has 41. It's, as we see here, niobium, so I'm going to write NB. So in that reaction, I'm going to get Nubia. Wish you understand this part and have a good day. Assalamu alaikum wa rahmatullahi wa barakatuh.